Good evening everyone. So today I'm going to discuss about digital systems, microprocessor and memory in avionics. My name is Abhishek Chanthakuri and I am an assistant professor. Okay. So in this lecture you're basically going to study about your processors, your microprocessor, your 8085 microprocessors architecture. Then I'm going to tell you some of the applications of your microprocessor, and then we are going to talk about memory as well. Okay, so processors, the digital processors, they came in the 70s, right? Say early 70s as 4-bit devices. Then by late 70s it became 8-bit and then 16-bit. The 32-bit Motorola 68000, this was used in your Boeing 777 as well as your European fighter aircrafts. But there was some issue. The problem here was basically because this is a small chip, so if there is a small damage on this chip, if there is a minor damage, what you have to replace the entire chip. Okay, so next let's talk about microprocessor. So what is a microprocessor? It is a programmable multi-purpose silicon chip, and this is clock driven and register based, that is going to incorporate the functions of your central processing unit. Okay, what it does, it accepts the data, okay, or in the form of binary data. It accepts the input in the form of binary data and then gives you the output as per as the instruction that is stored in the memory after processing. Okay, so after processing, whatever the instruction is stored, it is going to give you an output. Now a question arises, right? Why do I need a microprocessor? See, basically if you have a circuit, what happens if there is a circuit that is complex, your solution is going to be complex, right? So with the to make it easier, you need a program for it. If you have a program, you can make it easier. So I'll give you another example. Let's say you are trying to build up a house. Okay, what you need bricks for that, right? These bricks are basically your instructions. Okay, now if I give you this brick, you can design the house as you want. Like, so basically it has made it easier for you. So that's what a microprocessor does. Okay, so basically this is why it is useful. Okay, now let's come to your next slide. So I'm going to discuss about your 8085 microprocessor architecture. So how does a microprocessor work? Any microprocessor, basically what happens, see, you are going to give some input might be taken from either IO input or from interrupt control, anywhere you get an input. Okay, and your arithmetic logic unit is going to do your logical as well as your arithmetic calculations. Then these registers, you have your registers here, right? B, C, D, HL, accumulator, they are all gonna take this, they are gonna store this information after processing. Okay, I'm repeating what I just said. What happens in this, basically this arithmetic logic unit is going to get some input, right? So basically it is getting some input, and then it is going to do its calculation, and then it will be stored in these registers you see here, right? These are the registers where the information will be stored, and there is timing and controlling unit which is going to control your input and output. That means it is going to control the flow of data as per it is required. Okay, it is going to control the flow of data. So this is basically how it works. It takes information and then it does its addition, subtraction, calculation, whatever it is, and then processes it and gives you an output. Okay, so this is basically how a microprocessor works. So this is what you see on the screen right now, and basically I'm going to talk about all of this in the next slides. Okay, let's start with your configuration of 8085. Okay, so basically it's a 8-bit data bus, right? We know that it's a 8-bit data bus. This is 8 bits, so it's a 8-bit data bus. Okay, and it has a 16-bit address bus, and it can store data up to 64 KB. Okay, then we have your stack, your program, your stack pointer, your program counter, and then we have your registers. How many registers I have? A, B, C, D, E, H, L, and this is also A. Basically, these are 6 registers that we have here, right? B, C, D, E, H, L, okay? They are all 8-bit registers. Fine. Let's move to the next slide. Okay, so first thing, interrupt control. So see, what are interrupts? Interrupts are basically signals that are generated by some external device, right? For your microprocessor to do a task, a signal generated by external device. So it can be hardware, can be software, yes. So these are some of the inputs, right? Now what happens? For example, your microprocessor is operating, doing some program, okay? When there is an interrupt signal, okay, the microprocessor will stop whatever it was doing. Now what will it do? It will basically do what the interruption is telling it to do, okay? That means its focus will be shifted to this new thing that has come up. After this is completed, only the microprocessor goes back to its previous work, whatever it was doing, okay? Now the interrupts in your 8085. So basically your 8085 interrupts are your INTR, your RST 7.5, RST 6.5, RST 5.5, and your TRAP. Okay, good. So now I told you about the, basically I told you their hardware, software, right? We'll talk in detail about the type of interrupts. So we have your hardware, your software, your vectored, non-vectored, maskable, non-maskable. Okay, what are your hardware interrupts? See, when you're giving an interruption using some kind of a pin, okay, pin or a hardware, right, some kind of a pin, you're giving it, you're attaching some pin or something here, so that is your hardware interruption, okay, that is your hardware interrupts. What are software interrupts? When you provide some kind of a program, or where some kind of program is there in a microprocessor, then it is your software interrupts. What is your vectored interrupts? Now if your interrupt that you have provided, right, it has a predefined address, okay, it has a predefined address. That means the interrupt is not controlling the address of your microprocessor. So basically that is your vectored. And non-vectored, just the opposite of it. When the vector address is not known and it has been controlled by your interrupts that is providing your interrupt, if it has been controlled, that is your non-vectored. Then you have your maskable. What is maskable? These type of interrupts, okay, can be disabled or ignored by the microprocessor, okay. So some interrupts, right, which can be disabled or ignored by the microprocessors, these are known as your maskable. You apply a mask, right, so you're not allowing it to go, so it's up to the microprocessor, okay. Next is your non-maskable interrupt. This cannot be disabled by your microprocessor. For example, your TRAP, okay, this is, you see here, trap, yes, it cannot be disabled. So once this is set, done, you cannot change it, okay. So that is a non-maskable interrupt. This is the sequence. So trap has the highest, okay, and then priority, I mean trap highest, RST 7.5, 6.5, 5.5, and INTR, okay. Now what are the instructions for interrupts? So basically you have these instructions that you see on your screen: enable, disable, SIM, and RIM, okay. Enable input. So for setting your flip-flop, I'll come to flip-flop in detail in the next slide, okay. For setting your flip-flop, you are enabling an input, okay, you're enabling an input, but know that your flag, you're not making any change to the flag, you're enabling an input. That means you're giving some command to it, right? Now when you when your work is done, what happens? Again it will be disabled, so it will be set to reset. Now disable interrupt. If you want to reset your flip-flop, that is just basically you're resetting your flip-flop, that is your disable interrupt. Now what is your set interrupt mask? So let's say if your trying to implement some kind of a hardware, right? Hardware interrupt like a pin or something for generate, or by generating your output via your SOD. Here your SOD is, right? That is basically your serial output data. So if you are using, if you are trying to implement hardware, doing some hardware interruption, okay, then that is your set interrupt mask. Okay, then what is your read interrupt mask? To know the status. Now you have set, right? In your set interrupt, you have set something, you have given something, right? Hardware interrupt. Now you want to know the status of that. So reading that, that is your read interrupt mask. Basically your RST 6.5, 5.5, 7.5, these are your RIM and SIM. Okay, next let's come to the main part. I hope the thing still now is clear to you. Now what is your arithmetic logic unit? Okay, basically it is a circuit that does your arithmetic as well as logical operation. Okay, in this case it is 8-bit. Okay, it does things like XORing, ANDing, addition, subtraction, all those. Okay, that is taken care by your arithmetic logic unit. So basically there are three parts of your arithmetic logic unit as well. One is your adder. Okay, adder does your addition, subtraction, all those. Then you have your shifter. Okay, shifter is basically gonna shift left right, left right operation, and then you have your status, which give you the status of your results. So these are basically your operations that are available in your, these are the operations that are available in your arithmetic logic unit. Okay, now these units cannot be accessible by the users because they are of the microprocessor, right? So the users cannot access it. So basically it cannot be accessible, and it is gonna provide you the status or the result of flag register. Okay, now okay, let's move to next topic, that is your accumulator. Okay, so basically accumulator is a register that stores the data of whatever that arithmetic operation was done, right? Immediate data. As soon as that arithmetic operation is done, whatever data is there, that is stored in your accumulator. So it is here, and it is also called your A register. Okay, I told, right, B, C, D, E, H, L are there. This, where is A? This is A. Okay, this is basically A, that is your A register. Now next is your temporary registers. So temporary registers are this, what they are doing, you see the name itself, right? Temporary. So they are going to hold your data only during a arithmetic operation. Like you can have your temporary data as W and Z. Okay, if you want, you can show it in your array as W and Z. So basically they hold the data just for some period of time, right? Just for a period of time. That's why they are known as temporary. Okay, next, very important, your flags. Okay, so basically next we are going to talk about your flag register. So flag is basically a special purpose register. Okay, it can be set 1 or reset. If the thing is correct, set 1, otherwise reset. It depends upon your how the result is, what the value of your result is after your logical operations. Okay, 8085 has 8-bit, but we can only use 5, right? So we can only use 5 out of 8. So basically these 3 that you see here, 1, 2, 3, they are not usable. Okay, now first flag that I'm going to speak about is sign flag. So after any operation, right, after any operation, if the result is 1, okay, if the result is 1, it indicates that it's negative and its sign flag is set. Let me just give you an example. Okay, you are storing in A 40 and you are storing in B 50. Okay, now I want to subtract A minus B. So what I basically get, I'm basically getting minus 10, right? So what I had in A register I was storing 40, in B register I was storing 50. I basically wanted A minus B, so I'm getting minus 10. So your operation flag is S, like flag is set to 1, sign flag, right? If it was B minus A, then it is 0, reset. Okay, if it was B minus A, reset. Next is your 0 flag. So after any arithmetical operation, if the result is 0, then it is a 0 flag. So basically, if I want to store 10 in A, okay, listen to me, I want to store 10 in A and I have to subtract A. That means A minus A is basically 0. So that is your 0 flag. Okay. Okay, your MSB here is most significant bit. Okay, next, what is your auxiliary flag? Auxiliary flag is basically use your BCD system, that is 0 to 9, right? Binary code, okay, binary coded decimal. So after any arithmetic logic operation, if there is a carry, then this flag is set. After any of your logical operation, if there is a carry, then there's, let's say 39 plus 241, there is a carry, then this flag is set, otherwise reset. Parity flag. So after, now let's come to parity flag. So after any logical operation, right, if the result has even parity, that is even number of 1 bits, let's say even number of 1 bits, that means it is set to 1, otherwise false 0. Okay, this is your parity flag. Last is your carry flag. So let's, in carry flag, let's say when you are performing n bits of operations, okay, and the result is more than n bits, you are, let's say you are performing 10 bits but your result is 13 bits, so your result is more than, so that is carry flag is set, that is 1, otherwise reset to 0. I hope this is clear. Now let's talk about your general purpose register, that is this. Okay, so basically I have mentioned 2-3 times now, right? So we have your 6 registers, that is B, C, D, E and HL. Okay, HL is basically your last register, so it works as your memory pointer also. Okay, everything can hold 8-bit. Okay, everything can hold 8-bit, but when they work in series, they can hold up to 16-bit data. Okay, let's come to your special purpose register. So we have studied about your normal register, right? So now we come to your special purpose register. So basically there is program counter, stack pointer, increment, decrement. So these are the 3 that we have, right? So program counter, it's counting. Okay, it is basically counting your program. So what it does, it, a program counter stores the address of the next instruction. That means what is going to happen next, it is going to store first, right? This is very important. It is going to store the next instruction. Okay, so what happens, as soon as your arithmetic logic unit does a work, right, it is ready, right? So basically it's a 16-bit register. It is going to store the address of next instruction. Stack pointer is also a memory pointer, and what it does, it is basically going to store the address of last byte. This was storing your next instruction, this is storing your last byte. That means whenever you are whenever a data is loaded, the stack pointer gets decreased. That means whenever the data is loaded, your stack pointer gets decreased. Okay, this is your stack pointer. And increment, decrement, they are either used to increase or decrease. Okay, so they can be performed for any register, any memory locations. Okay, these are your special purpose register. Okay, next, address data buffer, address buffer. So we are basically going to talk about this. So from the contents of this stack pointer, right, they have to be loaded somewhere. So they are loaded in your address buffer or your address data buffer. Okay, basically what these buffer does, they actually drive your this what external data bus as well as your address bus. Basically they are acting as your driver. You can see it is also connected to your internal data bus. Okay, so it can be used to send and receive data. Okay, next is your instruction register, this thing right here, instruction register and decoder. So basically whenever there is some instruction that is been fetched from a memory, okay, it is stored in the instruction register. Some instruction is given, right? So it is first taken in and then it is stored in your instruction register. So it can be anything like adding a data, copying a file, right, moving something, etc., anything. So that is your instruction. Now that is instruction is given, there is a decoder that decodes like it, so that it can be used further or processed further. Okay, good. So next is your timing and controlling unit. So basically it is gonna control or time, right? Basically it is gonna synchronize the flow of data. Okay, so it consists of your oscillator and your control sequencer. Oscillator is kind of a clock that it works, right, with all the registers, and then sequencer, it sends control signals for all the control of data, means your external control of data. So sequencer just sends. So basically the timing and controlling unit controls your whole operation, right, flow of data and information. Okay, so timing and controlling unit signals are, so control signals, status signals, DMA, reset. Okay, ready, RD, write, ALE, yes, it's some latch. Okay, it is, yeah, address enable latch, that is your ALE. Then you have your hold and accumulate. Okay, and then you have your reset in and reset out, hold and acknowledge, hold and acknowledge. So basically these are some of the operations. Okay, so we have discussed about your microprocessors. Yes, 8085 microprocessor. I hope it is clear. Now let's go and take some microprocessors from your avionics industry that is used for flights. So basically the one I'm going to talk here about is PC7448. Okay, this is actually the power PCs, right? The power PC 7448 by Apple. Okay, basically this was your freelancers. Okay, the freelancer was a former of Motorola. Okay, this is a very powerful microprocessor. It can take up to 3000 dry storm, like MIPS performance. Okay, that means millions, right, instructions per second, millions instructions per second, dry stone millions. This dry stone is basically a microcomputer, okay, DMA microcomputer from your 1970s. So they are comparing the performance with that. It has got L1 and L2 cache like integrated. So cache is basically faster, it is easier, right? If cache memory, like it is easier from RAM. Basically L1 cache is like 100 times faster, L2 is like 25 times faster than your random access memory. So basically its L2 cache is somewhere around 1 GB and its clock is 1.7 Hz. If you increase it, it can go up to 2.7 Hz. So basically how much powerful is this, right? So this is used in avionics industry for flight computers. And one more thing about it, usually this company gives around 10 to 15 years, okay, of lifetime. But when it comes to your aircraft, you need another 10-20 more. So they deal with the manufacturer, they specially design it for your avionic systems. Okay, so basically another one is your power controls. Yes, your power PC is 5674. It is used for your engine control, since it is gonna operate at high temperatures between 150 plus 150 to minus 50 and all. So those temperatures it can operate, that's why it is used here. Okay, so basically that is your avionics. So now let me tell you some of the applications of microprocessors, right? Let's start with your electronics. So in electronics you have your digital clock, watches, mobiles, all those, right? Next, mechanical applications is your automobiles, your lathe, your remote controlling, everything. Okay, then we have your electrical motors. So electrical motors, in electrical we have your motors, power stations. Yes, medical we have your patient monitoring. Then we are even going to have your self diagnosis. Okay, all those comes in your medical. Then in your aerospace, aeronautical, we have your missile control guidance system, inertial navigation system, engine controls, flight controls, all those comes here. Okay. So basically this is your application of your microprocessor. Now some of the advantages of microprocessor. Why should I use a microprocessor? One thing, low cost. Okay, low cost, yes. High speed, okay. Then small size. Then I can say it is versatile, basically versatile, right? Low power consumption, less heat generation, okay. Low power, less heat, reliable, portable. So see, so many advantages are there. You can just list out, it keeps on going, the list keeps on going on. Okay, okay, yes. Again, the PC7448 Freescale technology. Okay, it was given by Freescale technology. So let's move ahead and talk about your memories. So we have spoken about your microprocessors in detail, and now let's come to memory. So what is memory? Like, you want to store some information for use in computer or any other application. You want to store an information, right? I am storing some information in my mind right now when I'm talking to you guys. So basically that is your memory, right? So what are the types of memory? RAM, ROM, and RAM can be further divided as your static RAM, dynamic RAM. ROM can be divided as your programmable, electrical programmable, and your erasable, electrically erasable programmable ROM. Okay. Now, memory. Yes. So primary memory. These are ROM and RAM, your primary memory, and then secondary CD, hard disk, hard drive, pen drive. All those are your secondary memory. So RAM is a volatile memory and ROM is not volatile. That means when the power is gone, yes, that means what happens when the power is gone, then the data will be lost. That's why it is volatile. Non-volatile means even though the power goes off, tomorrow also the thing will remain. Okay, let's go in detail. So RAM, yes. So basically what all you are performing on the CPU, right, or the program that you are performing, yes, that will be stored in this memory. So it is volatile. That means as soon as the power is gone, the data will be lost. Again, I can classify them into static RAM and your dynamic RAM. So static RAM, what happens, it is going to hold your power. As long as power is available, it is going to hold the things, right, contents. But DRAM, you need to recharge it every milliseconds. Okay, since it is holding for a long period of time, static RAM is faster. Okay, what about SRAM? It is going to use more power. Yes, basically SRAM is your cache. I talked about your cache memory, and DRAM is your main memory. Okay, now what is ROM? ROM, read only memory. So basically it is going to store the information, like you are booting a system. I am booting this device, so basically that is your read only memory, right? That means it is not volatile. Even if the power goes, tomorrow also my device will switch on. It retains its data, so that's why it is read only memory. Next, what are the classifications? PROM, EPROM, and E2PROM. It is EEPROM, you can say. Okay, so PROM, it can be programmed by the user. That means I can program this type of memory, right? But once programmed, I cannot change. Instructions cannot be changed. EPROM, I can reprogram it by using ultraviolet rays. If I use ultraviolet rays, I can reprogram it. E2PROM, I don't need my ultraviolet rays. I can even use electrical field to restore it. So that's why it has significance in your aircraft, where your digital data buses can be used to reprogram. Okay. Okay. Again, the same thing, just a revision. Differentiation between RAM and ROM. One is volatile, non-volatile. That means, again, you know that, right? Power, no power, doesn't matter. Then temporary storage, permanent storage. In this case, the data is stored in MBs. This case, the data is stored in GBs. Writing of this takes a lot of time. In case of your ROM, this is faster. Okay, this used for normal operation, that is used to boot up your system or startup. So that will conclude your session for today. Thank you very much. Have a good day and keep smiling.